Great, here we have multiple choice problems number 14 and 15, and we will need a calculator for number 14. So we're being told we have temperature as the constant, and the rate of change of barometric pressure P with respect to altitude is proportional to P. So that means dP dH is proportional to P. So this is a growth and decay equation. So if I go ahead and skip the separate, integrate, solve, and just write that P equals AE to the KH, that will give me my general solution. So then they're saying if I plug in P equals 30 at H equals 0, sea level will be H equals 0. So when H equals 0 and P equals 30, let's see, that gives me an A value of 30. It's the initial value. So that gives me this equation. And I can then find out my K value by plugging in P equals 29 and H equals 1,000. So if I plug in P equals 29 and H equals 1,000, I can solve for K on my calculator. So that means I need to use the solve key. Make this a little bit bigger here so we can see it. Use the solve key and then hit 29 equals 30 times e to the 1,000, and I'll just use x instead of looking for the k value, and then solve it for x, so put comma x and enter. And I'm going to go ahead and get a decimal approximation, so I highlighted it, hit enter to bring it into the row, and hit green diamond enter. So my k value here is 4 zeros and a 339 and negative, so k equals negative 4 zeros and a 339. So then they want to know the pressure at 5,000 feet. So to get that, I need to go back to my equation. P equals 30e to the negative 0.0000339 times my h value is now 5,000. So let's go back to our calculator, and we're going to plug in 30 times e raised to the 5,000 times, and I'm going to grab this answer from above and bring it into the line. Notice that when I do that, it says x equals, so I'm going to scroll all the way over and get rid of that x equals. And I end up with an answer of 25.322, which is choice B. And then the last problem on this page is they're giving me this slope field, which looks like the solution is quadratic but shifted right. So which one could represent the differential equation? Well, you'd want to be able to integrate the differential equation to get to a quadratic. So my initial reaction is going to be one of these guys, A or D. But let's do it like this. If I read across the rows, the y value, if I read across a single y value, the slopes all change. So that means that y does not drive our slope. If I read up and down, I notice that the slopes are all the same, so x does impact the slope. So I have to cross out C and E, which have y's impacting the slope. I'm also going to cross off B because this is definitely not sinusoidal. I see nothing periodic about it. So then last, I think I'll just, if I plug in x equals 0, I should get a slope of 0. That's not happening here. So for A, if I plugged in a slope of 0, I should get a slope of 0. That's not happening, so it's got to be D here, which makes sense because there's got to be some sort of right shift, and that's what's happening with that -1. But if I plug in an x equals 0, I should get out a slope of -1, which is what's happening over here. So my answer choice is D.